everyone. Good evening, and thank you for joining us today. We're going to be talking about deep tech. What comes to mind when you think about deep tech is often scientific labs and geeky founders and very complicated applications. But behind, we know that there is an intrinsic, complex work of engineering and a lot of patience. Right? So to help us dig into this and get a bit of insight into what goes into a deep tech company, we are very honored to have three very talented deep tech entrepreneurs. You already got introduced to Mar. Her company, Bit-Tronics, has created a sophisticated AI vision software that basically enables industrial robots to see, right? And that enables them to do very, very complex tasks with high precision. Which is really interesting. In the case of Roman, his company, he's founder of Expanseo, which is a company that is creating an incredible interface, which is almost weightless, basically, and very, very thin, and goes into your eye as a contact lens, and basically brings a layer or layers, basically, digital world into our reality, which is also really interesting. And in the case of Barbara, she has created a highly specialized search platform that helps scientists, engineers, and technologists to find with precision the right type of photonic components in order to enable their own and empower their own technology innovations. So thank you all for being here. First question, the path from laboratory to breakthrough as a viable product is notoriously difficult in deep tech, right? So what kind of invisible hurdles did you have to overcome over the years in order to make that reality? Especially those things that you had maybe anticipated as or not anticipated initially. What would be any of you?
Well,
yeah, go ahead.
When you are developing deep technology, you often go outside and people are thinking you're talking about science fiction, right?
Yeah, exactly.
So there is a huge amount of people that is very interested, but they are more interested in awareness rather than adoption. So this is a journey. We need to be very focused on ensuring our technology is adopted at a certain point in time. It goes with maturity and also with explaining what you are doing, educating the audience very often.
Yeah.
When we started talking about artificial intelligence in 2017, that was crazy. Mm-hmm. They were thinking, we were like talking about a film rather than real science that we were making in our lab.
Excellent, interesting. And what about you?
Yeah, it's very interesting. I feel highly related to this answer, especially with investors. Sometimes when we talk about optics and photonics, they look like, what is this about? They don't really understand maybe that this is technology that is behind all high tech that it's happening. But they know about quantum cryptography, they know about autonomous vehicles, they know about surgery with lasers, but they don't understand that the technology behind that enables these technologies to happen is actually optics and photonics. So it's very interesting to see this unawareness of the deep tech.
So investors not only know everything they think they know, right? Maybe sometimes they lack patience.
Speaking about the investors, I would say that the biggest challenge was, fundraising with this amount of tattoos. but frankly speaking, we as a company, we create contact lenses with digital functions, and this is not a pitch, not a PDF slide. We already do have working prototype and 32 patents. At the beginning, there's always a passionate person, someone who has to persuade the world, the investors, and even the team who is going to build the product that it's possible. And then, when you persuaded those three types of people, you probably need to persuade the world that the world needs this product. So I would say that the biggest hurdle and the mission of a founder is to constantly provide team, investors, market, and general public with certainty that your envision of future is going to happen.
True.
Okay, that's an interesting point. And one common theme that comes to mind when looking at your respective companies is that all of you are basically creating a foundational technology that many others can also use and leverage to build upon with the respective technologies. So how do you foresee that technology being built up by other entrepreneurs? Maybe there's some of them here in the room. How do you foresee that? You see that already happening?
In my case, I see it through applications because we create the layers of that technology. We have the configuration software, then you have to make it happen and scale, right? And because the technology itself needs to be, it is not software only, you need to build something that's useful for a particular vertical in the market, and that requires integration with cameras, integration with robots, integration with any other gripper or whatever you may need. And this is why use cases are so important.
Exactly, yeah.
Very easy. In order to create such a gadget, we decided to create. We, at some point, we understood that we cannot rely on whole generation of tech based on silicon, because silicon is simply too bulky, too big. There are some companies, especially in the US, who already did create such a gadget and even brought it to market based on silicon era technologies, but we understood we need something else. That is why we had to, well, the core technology behind the, we decided that we need to create our own material thin enough in order to create electronics out of it to put it onto contact lenses. That is why we didn't have anything but to create, but to invent at least 3 new two-dimensional materials, materials 1/8 and thin, and to learn how to build electronic components out of those materials. Today, there are about, I think Barbara will correct me if I'm mistaken, there are about 120 two-dimensional materials discovered. I'm really proud to say that at least 3 of them were discovered in our lab, and very soon the world is going to profit from those materials and will be able to use them anywhere, starting from, you know, creating gadgets to basically to medicine, co-working,
yeah.
new way, well, you name it, any kind of area of social interactions between humans will be affected by this.
Interesting.
That's
Excellent.
super, yeah, super cool. So you guys do actually like R&D that afterwards people can use. So it's super use, like a small lab that you have. In our case, we've built the largest database of products in the optics and photonics industry, which is the only one that is up to date and technically standardized. So that means that people can compare products across different manufacturers. And the layers that other industries can use our database is, for example, an optical design firm that they have engineers using their softwares to design components. They want to access our database to provide their components to their design software tools. And this happens with optical designs, but also mechanical parts and other parts. So it's very important to build layers and that we all work together, because it's very expensive as well, R&D, right?
Yeah.
So,
Exactly. I mean, maybe you find
Deep tech is not only deep, but notoriously expensive.
it's expensive.
especially in the sort of the startup world and in deep tech, which is by definition quite intensive in terms of investment, you need to find ways to sometimes collaborate with third parties or join forces with others and focus on the core technologies, right? Because you can't cover everything as a young company, I assume. Let's go into some of the more specifics. In your case, Bit-Tronics, Mar, you focus on giving the robots the sense of sight through AI. It's a robot that can see and therefore can pick and do complex tasks. So are we correct to assume that the secret sauce or the invisible engine behind that drives the innovation there is in the software?
Absolutely. It's Bitmetrics, by the way, my company. At Bitmetrics, what we do is enabling software so that robots can adapt to a context that is changing. The change can be different pieces or different items, or working with conveyor belts that are moving things. So we need to provide decisions in the millisecond range, which means that has to be really, really accurate on the one hand, on the other one, precise. Software is embedded in everything. I think for Europe, this is critical. I think this is the chance that we have to continue to be on the wave, on the top of the wave, because hardware, we lost some capacities, and we need to see them perhaps as enablers of the technology itself, but not as the foundation. Yeah. And I think this is a wise decision we had to make at some point in time, not to compete on hardware, which was one of the possibilities.
Of course. And what about access to data? Because often when we talk about AI, one of the challenges is usually getting access to data sets, that are, good enough, to develop the AI and train the algorithms, etc. Was that also quite a bit of a challenge in your case?
It was at the beginning,
okay.
Not now. We have created our own data sets, which is also critical. Computing power is a must. The thing is that we in Europe do not have access to all the computing power that they have in the States, for example, or in Asia. So that's another of the big challenges. We might not be able to find even certain graphic cards that are needed to compute such a large amount of data. It is also important to say that in the manufacturing industry, clients do not want you to process their data in the cloud. So you need to take care of that as well.
Of course.
And latency in communications play a part. So you need to also execute all the applications on edge computing. That's part of the deal.
Interesting. Let's go to Barbara. In your case, can you elaborate a little bit about the complexities behind this standardization of such a heterogeneous, highly complex, components that keep evolving, I guess, right? Because it's not a static, range of components. It keeps evolving very rapidly.
So I think the first complexity is very technical, but has been overcome with many companies, which is the data sets that we receive are in many, many different formats. They could be like a PDF, a website, an API through the database of the supplier. It could be they give us an Excel with all the information. So this is relatively okay. We receive that and we standardize it. The problem is that once in the standardization process arrives, it's very easy to standardize things that everyone understands, like a table has 4 legs. So more or less an engineer could understand these are legs that is made of wood or metal, okay, plastic, they understand those words. But when it comes into photonics, the engineer that needs to do the standardization of the technical aspects are very complex. We're talking about peak power, pulse duration, rep rate, signal to noise, scratch dick. So some specifications for those products that they need to understand in order to standardize them. So we started having a very strong PhDs and start doing this technical part of the standardization. Now with AI, we went to like a very, very deterministic database creation to a more scalable part of understanding the specs while being very, very accurate.
Interesting. And what about customers that don't know exactly what they're looking for? Because you may get some of those, right?
Exactly.
Are you helping them to find what they need, even when they don't know exactly what?
Yeah, sometimes people think like, okay, you're a physicist, you're an engineer, you know everything, and that's not true at all, right? So every engineer, the first part is that they have a challenge and they need to overcome and understand what they need. So Up to probably like a few months ago, Metoptics was only used for engineers who knew exactly what they wanted, and then they could find it on the platform. Now we have an AI assistant that helps you depending on your application. For example, you say, I want to cut 3 millimeters of metal. Which laser do I want? And then it tells you, okay, for this you need this peak power, these wavelengths, and this would be the laser that you would need. So now with AI, everything gets much better.
AI, I have to ask Roman as well about your AI. I'm sorry. How does that AI, in your case, play into the...
We really do believe that the next generation of computing is an AI-powered XR computing. Think of it as a computer of Tony Stark, the Iron Man. Remember the movie? Blink, an interface appears around you. You operate it by your eyes, by voice, by gesture. The central piece of this interface is Jarvis, his intellectual helper. We develop one of the interfaces for this future AI. Right now, we live in the world of apps squared into square glasses. But imagine the world when you just want to, hey Meta, hey Google, hey ChatGPT, I want to listen to this song. You do not care whether it's going to be played through Spotify or YouTube Music or Apple Music, you just don't care. You want to listen to this specific song. Imagine telling this, your intellectual helper, I want to listen to this song. And it turns the song on, and you operate it, the volume, the everything, with eyes, with gestures, with everything. Thing is, you will need multiple form factors. Today, to use our current state of technology and software and apps, we need multiple gadgets. When we're at work, we use laptop, phone, probably tablet, God knows what else. Me personally, I gather at least 5 computers throughout the day just to survive a day. Same is going to happen with the next generation of this AI computing. The key difference is the thing that those interfaces, the coming interfaces, they're going to be more seamless, more comfortable, more human-centered, more easy to operate, and closer to human body. Each generation of computing is smaller and closer to us. While at work, you will wear your headset. While walking, you will wear your glasses. While jogging or working in a harsh environment or in space or driving a motorbike or whatever, you will wear your contact lenses. This is basically a future we envision. And this future is very, very close. I'm sure everyone here saw this latest presentation of Google where they presented Google Android XR and basically have shown at least two new gadgets to operate their proper AI technology. Apart from that, of course, we use AI and machine learning algorithms a lot, hell of a lot, while developing the gadget. We wrote a specific algorithm to help us create new materials and have gathered a very substantial data set to feed this algorithm. And this algorithm has shortened the cycle of developing a new material for at least by 22-23%. So AI is very helpful while creating an interface for AI.
Interesting. Excellent. Maybe let's look at the sort of market dynamics, right? Because it all sounds really interesting, very futuristic. What about the reality today? I mean, in your case, for example, BitMetrics, how is the end customer receiving the technology? Are they ready? Because sometimes it happens when cutting-edge technology that the customers are not yet ready to adopt. How are you seeing that process of adoption?
Well, I think it has improved a lot. Well, thanks to ChatGPT. But that's true. I mean, when you go into a room and talk to the client and showcase whatever could be done with AI, they are no longer scared, and they put their eyes and their ears to what you're telling. It is true that we are part of the enablers, as I was saying before, so we need to cooperate. For me, the key thing here is technology is based on cooperation. There is no one single solution that fits it all, so you need to work with a robot provider, with a gripper provider, with the engineering that will take care of maintenance, with the one that will put the CE seal so that the state it is secure to use, that it can be used by humans, and so on, so on, so on.
The adaptability is very, very important, right?
Absolutely. But the clients are seeing the efficiency, and the most important thing is they are open to change. And they are open to see what else their workforce can do, because no longer young teams want to do repetitive tasks.
Excellent. And Meet Optics, that's a particularly interesting case because it's a marketplace. So you need to build, you have customers on the supply side, the customers on the demand side, and that's always a challenge. You need demand to attract supply, but you also need supply in order to retain demand. How do you overcome that?
Luckily, as there's always something called early adopters, and then you stick on them to bring some value. We created a technology that it's free to use for engineers and researchers, so they see it as a tool that it's free for them. So they use it, they give us feedback, they create a community behind. And this helped us grow, especially the first years where the offer of the products were not so high. So when the engineers were saying, hey, nice idea, I was like, it's a product, it's not an idea, use it. And until we built in 2023 the largest database in the industry, now they send us an email saying, hey, thank you, I used it for that, now my experiment went faster, I found this new company, so now it's different. But the first years, it was an idea for them and not an actual product. Yes, so it took time.
Interesting. I think, Roman, we're all waiting to know when we're going to see those contact lenses in the market. What are your plans?
Three statements. Our company, well, humanity have been trying to create this gadget for 20 years already. And there are at least a few companies, mostly from the US and South China, I would say, that have already created prototypes, and our key competitor and guys we absolutely admire, Mojovision, American company, their CEO approached the press wearing the prototype, using the prototype. So when will you see humans using them? Type YouTube Mojovision lens or Expansio lens. You will see our prototypes. When it's going to be widely adopted? Two statements. Meta, Apple, and Google are on the race to create headsets and glasses, and all three big techs are going to present their smart glasses somewhere within 2026, 1 year. Second statement, check sales of MetaQuest 3, the famous headset, infamous I would say, the famous headset from Meta. They sold, if I'm not mistaken, they sold 14 million copies the last year, which I might be mistaken, but thing I'm certain about is the fact that they sold more headsets than Apple sold Apple Watches. And
it's going to happen soon, and it's going to be
it has already
quickly.
happened.
Perfect.
It has already happened.
Okay.
But right now we're talking about millions of people using XR gadgets around the world. The world has noticed iPhone 15 years ago when hundreds of millions started using it.
Yeah.
So I would say wide adoption is somewhere within 3 to 5 years of XR gadgets.
Okay, we take note of the dates. And outside of your fields, maybe we only have a minute, but maybe in 25 seconds each. Outside of your fields, what are other technologies that right now most excite you, looking ahead, looking into the future? Any of you? Is there anything out there that you are particularly, whether it is quantum or
humanoids.
humanoids?
Humanoid robots.
But don't worry, they won't be here in the next
That's
decade.
another world, another company perhaps in
Yeah,
a few years.
absolutely.
Right?
No, yes, but no, I mean, we are seeing very closely,
Yeah.
and they are far away from
Yeah.
best adoption. There are a lot of technical issues that need to be solved yet.
Interesting.
I-
Any others?
I would say, for me, we don't know the solution yet, but more efficient data centers. So the way data is processed,
Data.
it's not very efficient. And brain processes data in a much more efficient way, in a different way, which is
In a more sustainable way.
and more
as well,
sustainable.
probably,
So I think they will go somewhere like there's going to be a breakthrough. Well, that also AI can grow. No, we need a breakthrough on how data centers process data.
yeah. Interesting.
Neural interfaces.
Last 20 seconds.
Neural interfaces.
Interfaces.
AI
Neural.
plus XR plus neural interface, merge it, combined with the human body, you will get a new type of human. A human that is able to operate the whole bunch, the whole information produced by humanity so far with his mind, and basically operating this information just by thinking about it.
Interesting. So direct connection to the brain.
Absolutely mind-blowing.
Mind-blowing, indeed. On that note, that's all we have time for. Thank you, first of all, to our guests, and thank you all of you for listening. Thank you.